Hello all, today I'm going to be discussing the role of vegetation in reducing atmospheric carbon and global warming. In this presentation, we're going to be focusing on juxtaposing a news story with a primary literature article and discussing the implicit biases this news story might have according to its data that it presents. So moving on, we're going to see the overarching theme is the effects of deforestation on climate and carbon dioxide emissions. Basically, this conversation kind of connects to Bio 1 DD2 because ecosystem ecology is split into biotic and abiotic factors. Abiotic factors being that climate and carbon that is released to the atmosphere, and then the biotic factors being the animals and vegetation that are affected by that climate and carbon emissions. It's also going to link to the nutrient cycles, where carbon one specifically, where carbon comes in through photosynthetic processes and then is released through cellular respiration within the ecosystem. And then we're going to discuss human impacts on the environment, such as logging, where when we take away forests, we're going to ultimately decrease biodiversity, increase global warming, and cause catastrophic changes to the environment and the organisms that reside there. So basically, for our news story, Amazon is less able to recover from droughts and logging, study finds by Henry Fountain. He's basically really emphasizing that carbon and warming will increase once we deforest tropical rainforests, such as the Amazon specifically. And he quotes that the rainforest could result in up to 90 billion tons of heat trapping carbon dioxide to get put back in the atmosphere. This is big, this is catastrophic, and he uses a lot of bombastic language to do this. We basically see in our primary literature article, The Unseen Effects of Deforestation, Biophysical Effects on Climate by Lawrence et al. She basically discusses how forests sequester large quantities of carbon, specifically 450 to 650 pgs of carbon is stored in vegetation. And this is through three biophysical mechanisms. Albedo is one of them. Albedo basically demonstrates that the foliage absorbs a lot of the heat due to being of a darker green and, chlorophyll. They also demonstrate that forests play a role in evapotranspiration, where they form clouds that reflect the sun's radiation from the surface of the earth. And they also discuss canopy roughness, where canopies often create BVOC emissions, which are biogenic volatile organic compounds, which reduce warming, specifically because they regulate secondary organic aerosols and their oxidations. Moving on to the methodology, we see the use of in situ observational studies specific to organisms, and then we also see remote analyses such as satellites being used to kind of compare and contrast the temperatures of forested areas and temperatures of deforested areas. Basically, as we can see in the results, as we deforest forests, we see that there is a greater change in temperature. In the light green, we see less deforestation and then therefore less change in temperature. And we can see that when we deforest, the albedo effect will actually be most greatly impacted in reducing or in causing now an increase in global temperatures, because we won't have that foliage to absorb the heat waves. Now, moving on to discussions and conclusions, they discuss how max temperatures will start to increase, harming biodiversity, causing death of animals and death of species. We see that when we reforest areas, we cause a 3% basically warming reduction. So we're decreasing the amount of warming that's done there. And then future process deforestation could harm the land by 25%. Current issues with methodology include distinguishing between latent and sensible heat, latent heat being related to changes in phase when something's heated, whereas sensible heat, it heats up, but it's not going to change from liquid to gas or gas to liquid or solid, any of that. Basically, the main differences between the news article, the primary source news article does cite professional analysts. However, they don't really tell us where the data is extrapolated, and they do not basically let us know the biophysical mechanisms that the forest kind of controls. So basically, we can conclude that even though the article uses a tone of urgency and doesn't really compare other regions, we say that it is valid because the data does corroborate between that biodiversity and climate go hand in hand. Here are the references. Thank you so much for your time. I greatly appreciate it.